Bismillahirrahmanirrahim. It's me Abdur Rahman and I am here to present my topic the phasor diagram. In simple way, if I say this phasor is nothing but the simple way of representing a sinusoidal signal. So now when we have more than one such sinusoidal signal which is having same frequency but the different phase and different amplitude, then we can use this phasor diagram to represent the phase difference between the sinusoidal signals. So now we know that any sinusoidal signal in general form can be expressed by this expression, that is Vm sin omega t plus phi, where Vm is peak amplitude of this sinusoidal signal, omega represents angular frequency and the phi represents the initial phase of this sinusoidal signal. So now let's represent this sinusoidal signal using this phasor. So now this phasor is nothing but a vector which rotates around its origin at the constant speed of omega radian per second in the anticlockwise direction, and here the length of this vector represents the maximum amplitude of this sinusoidal signals, and its angular velocity represents the angular frequency of this sinusoidal signal. So now if we take the projection of this rotating vector on the y-axis, then we will get the instantaneous value of this sinusoidal signal. So now as you can see here, as the vector rotates in the anticlockwise direction at the speed of omega radian per second, and if we take the projection of this vector on y-axis, we will get the instantaneous value of this sinusoidal signal. And if we plot all the values which are possible for this phasor, then we can reproduce this sinusoidal signal. So now let's see how we can represent this phasor on phasor diagram. So now on this phasor diagram, different AC sinusoidal signals which are having the same frequency but different amplitude and different phasor are represented. So while representing these phasors on this phasor diagram, we only represent them by their amplitude and initial phase. So let's say we have two sinusoidal signals. The first is, let's say, phi sin omega t plus 30 degree, and the second signal is V2 is equal to tan sin omega t plus 80 degree, and we want to represent these two signals in terms of the phasor on phasor diagram. So the first signal is phi sin omega t plus 30 degree. So first we will draw the vector which is having the amplitude of 5, and it will make an angle of 30 degrees which the horizontal axis or reference axis. Now if you see the second signal, that is tan sin omega t plus 80 degree. So here peak amplitude of the signal is 10. So we will draw vector which is having the magnitude of 10, and it will make an angle of 80 degree which the horizontal axis. Now sometimes this phasor is also represented by the RMS value of the sinusoidal signal. The reason is that the most of the measurement which is being carried out by the ammeter and the voltmeter are in terms of the RMS values. So sometimes you will find that these phasors are represented by the RMS values instead of the peak value. But in this video, we will consider the peak value of this sinusoidal signals. So now let's see one more example based on this phasor diagram representation. So let's say now we have voltage that is equal to 10 sine omega t minus 30 degree, and the second voltage or second signal is 5 sine omega t minus 120 degree, and we want to represent those signals on the phasor diagram. So the first signal is 10 sine omega t minus 30 degree. So we will draw a vector which is having an amplitude of 10, and it will make an angle of minus 30 degree with the horizontal axis. Now second we will draw the second signal which is having an amplitude of 5, and it will make an angle of minus 120 degree with this horizontal axis. So we can draw a vector of 5 volt amplitude which is having a phase shift of minus 120 degree. So this will be the representation of V2, and this will be the representation of V1. Now on this phasor diagram, this anticlockwise direction is known as the leading direction, and this clockwise direction is known as the lagging direction. So as you can see here, this V1 is leading the V2 by 120 degree minus 30 degree, that is by 90 degree. So here this V1 signal is leading the V2 by 90 degree. Similarly, in the first case, if you see this V2 signal is leading the V1 signal by 80 minus 30, that is by 50 degree. So now so far we have seen that how to represent phasor on phasor diagram. Now let's see how we can represent this phasor in mathematical form. So suppose we have phasor which is having amplitude of Vm, and it makes an angle of phi with the horizontal axis. Then in polar form we can represent it as Vm and phi. So the next form is a rectangular form. So in this form we can represent any phasor by the complex number, that is a plus jb. So the amplitude of phasor will be under root a square plus b square, and the phase of this phasor can be given by expression tan inverse b by a. So this will be the rectangular form of representation of this phasor. Now the third form of representation is the exponential form, where we can represent the phasor in terms of Vm e j power phi. So these are the basic three representations by which we can represent this phasor.